Hello friends, today we're going to be looking at advanced algebra. Now in our previous exposition, we worked on basic algebra and we finished up everything on basic algebra. So today we're going to be looking at advanced algebra. So when we talk about advanced algebra, don't forget that there's an upgrade on basic algebra. So when we talk about advanced algebra, what are we talking about? Now under advanced algebra, we mainly talk about equations and expressions or expression. So when we talk about equation, what does equation means? Now, equation is gotten from equality. Now, when we talk about equation, it means there's a balance between what we have on the LHS. LHS simply means left-hand side, and what we have on the RHS, right-hand side. So there can be, what we call equity or what we call a balance if what is on the LHS is not equal to what is on the RHS, which is right-hand side. So when we talk about equations, it means balance. It means the two sides are balanced, the right-hand side and the left-hand side. So when we talk about expression or expression, now the major difference between expression or expression and equations is simply the presence of equality sign. This equality sign is what differentiates them. Now this is 2x equals to 3y, where this is 2x plus 3y. Now so that's a major difference. This is equals to this. This is balanced, while this is just like some of the stuff we worked on basic algebra. So now there are different kinds of equations and expressions. We have different kinds. So the first we have here is what we call the linear equation, or sometimes it could be expression. Don't forget, equation and expression are virtually the same thing, but the major difference between them is one has equality sign and the other one doesn't have equality sign. So now when we talk about linear equation, how do we get to know a linear equation when we see them in a question? How do we identify a linear equation? Because that's one of the major challenge. Now every linear equation has the highest power to be plus 1. Now when we talk about linear equation, the highest power for every linear equation is positive 1. Now look at this. If you have x to the power 1, now don't forget that this is a base, this is a power, this is a base, this is a power. So when we talk about linear equation, every unknown or variable has the highest power to be positive 1. So this is x to the power 1, this is x to the power 0. So look at this example. This is ax plus b. So this is ax, this is x to the power 1. Then the b here is bx to the power 0. So this is a pure linear expression because there's no equals to. Now once I add my equals to it, this becomes a linear equation. But this is linear. Why is it linear? It's linear because the highest power we have here for this unknown is x to the power 1, while this is x to the power 0. Whatever x raised to the power 0 is 1. So that's that for linear equation. So the next you're going to be looking at is quadratic equation or quadratic expression. Now for quadratic equation or expression, the highest power is plus 2. So that means we have something like this, x to the power 2, x to the power 1, x to the power 0. So it's going to be descending from the highest power to the least or lowest power. Don't forget, highest power is plus 2, not really minus 2, plus 2. So look at this example. This is as squared. That's x to the power 2 plus b. Now watch out. The a, the b, and the c, they are all coefficients, while the x to the power 2, x to the power 1, and probably x to the power 0 represent the unknown or variables. So this is as squared. This is bx, x to the power 1. This is x to the power 2. So what's the highest power? The highest power we have here is 2. You can see that plus 2, and that's why we call it quadratic equation. Now this is a quadratic expression because there's no equals to. Now once I add my equals to it, equals to 0, equals to whatever, it becomes a quadratic equation. So the next we're going to be looking at is what we call the trinomial equation or trinomial expression. Now for trinomial equation or expression, the highest power is plus 3. So we have the highest power to be plus 3. So we have something like this, x to the power 3, x to the power 2, x to the power 1, and then we have x to the power 0. So that's what we have. So we have an example like this, a trinomial expression. This as cubed plus bs squared plus cx to the power 1 plus ds to the power 0. As you can see, this descends from 3, 2, 1, and down to 0. So this is trinomial. Now, how do we get to know trinomial equation or expression? The highest power is positive 3. So the next we have is polynomial equation. Now look at the word poly. Now this is not linear. This is more than linear. It's more than quadratic. It's more than trinomial. This is poly. So when we talk about polynomial equation, the highest power is plus 4 or more than plus 4. So we have it could be s to the power 5, it could be, it could be 4, it could be 5, it could be 6, it could be whatever. So we have an example like this: s to the power 5, s to the power 4, s to the power 3, s to the power 2, s to the power 1, and then s to the power 0. So we have this. Look at this polynomial expression: ax to the power 5 plus bs to the power 4 plus cs to the power 3 plus ds to the power 2 plus ex then plus f x to the power 0. So as you can see, this is a typical polynomial expression. Once you add an equals to it, it becomes a polynomial equation. So the next we have about 2 more to go. The next we have is what we call the indicial or exponential equation or expression. So this is called indicial or exponential equation. So yeah, this one simply deals with indices, basis and power. That's we have to work on the laws of indices. We need the basic knowledge of the laws of indices for us to understand this. So now, what's this all about? Powers are mainly the unknowns. So when we talk about indicial or exponential equation, we mainly talk about powers, coming in form of unknowns or variables. As you can see, this 2 raised by s. Now, when you compare or juxtapose what we have here with others, if you look at this s to the power 5, s to the power 4, most of the powers here are all numbers. They are all figures. They are all, they are all coefficients. I can say that. And this one's also, just look at the rest. You can see, if you try to compare what we have up there with this one, you can see that here the power is, it's an alphabet, it's a letter, or I can call it an unknown. So this 2 raised by x, then 3 raised by minus y, and so that's that for indicial equation. So we have a major example such as this. This 2 raised by x is 2 minus 2 raised by 3 minus x. So that is that for indicial or exponential equation. So the last equation we're going to be looking at is what we call simultaneous equation. Simultaneous equations, or sometimes it's been pronounced as simultaneous. So this simultaneous equation, and now when we talk about simultaneous equation, the word simultaneous itself is mainly an English word that means two or more things being done at the same time. So we talk about simultaneous equation. We're talking about any of the above listed or stated equations being solved together at the same time. So it could be 2 linear equations, 3 linear equations. It could be 1 linear, 1 quadratic. It could be whatever. But what we know is we are solving 2 or more equations at the same time, and that's what we call this simultaneous equation. So I would love you to learn all these equations, because in the next exposition we're going to start with linear equations. So it is very important that we learn all these equations. Now you have to go ahead and learn them and see the difference, the major difference between them. So at this very point in time, we're going to be calling today's lesson. We are going to be calling it today. So if you have found this lesson resourceful, please subscribe to this very channel and share this with others. So at this point, I will say thank you. See you in the next exposition. Bye for now.